955 PLN's VRE and RUPTL Variable Renewable Energy VRE Development Strategy. EBT generators, especially intermittent or variable renewable energy VRE plants, both utility scale and distributed, have different characteristics from other types of generators, so that in their integration into the system, attention must be paid to and fulfill these and the following. First, energy production from PLTS and PLTB must be predicted with weather forecasts due to their intermittent nature. In order to maintain system stability, PLTS and PLTB production must be predicted accurately, so the development of PLTS and PLTB generators must be equipped with weather sensor equipment. For example, pyranometer for PLTS and anemometers for PLTB, as well as other sensor equipment, which must be integrated with the communication system in the PLN control center so that it can be monitored and has a solution within a certain time unit. Second, the production of PLTS and PLTB does not disturb the stability of the system. The intermittent character of PLTS and PLTB, so as not to disturb system stability, can be anticipated by one or more solutions, including A, installation and operation of equipment for automatic frequency regulation and automatic voltage regulation for all conventional power plants. Both existing and new power plants must comply with the applicable network regulation. B, changes in the operating patterns of generators with high stream rate capabilities that are adapted to the operations of PLTS and PLTB. Installing a battery energy storage system BESS as buffering. D, PLTA pumped storage with variable speed drive technology on pump motors. E, other buffering solutions. Third, anticipation is needed for a VRE generator connected to the system using power electrics because it has no inertia, so several solutions are needed, including A, changes in operational patterns of large-scale conventional thermal generators that are operated to maintain system inertia, but the loading is not at the most optimal conditions. B, inverter technology that is able to respond like a thermal generator governor virtual inertia. C, distributed synchronous condenser installation, a priority for existing generators that are not dispatched. Fourth, it is necessary to anticipate the dark curve as a result of the massive production of PLTS and rooftop PV in the distribution network during the day, including A, utilization of generators that have a high lean rate, such as hydropower, pumped storage, PLTG, MG, and BESS. B, a determination of the minimum technical load of base plants, such as core PLTU and PLTP, both technically and contractually. C, determination of gas contracts that can adapt to the operating patterns of PLTS and rooftop PV. D, the utilization of coal-fired power plants in Germany and Denmark has been modified retrofit to be able to operate with a lower technical minimum load and a higher lean rate and to function as a load follower to compensate for the intermittent from very large solar power plants. Further studies are needed between the application of retrofit, which has quite a large cost compared to building a gas-fired load follower plants, which has a cheaper investment but higher operating cost. Fifth, every power electronic equipment is in PLTS and PLTB that is connected to the system at least has following features. A, low voltage ride-through capability, so that when a disturbance occurs in the system which causes a voltage drop, it does not cause the PLTS, PLTB to go on the trip. B, the ability to support voltage like other types of conventional generators listed in applicable network rule. C, low frequency ride through capability, so that when there is a disturbance in the system which causes a decrease in frequency, it does not cause the PLTS PLTB to go on a trip. D. The ability to have frequency control, namely when the system frequency rises but the power output from the PLTS PLTB falls, and when the system's frequency drops, but the power output from the PLTS PLTB must not decrease, stay. All of the above solutions must be coordinated and fulfilled from the start of the development of EBT generator with an intermittent nature VRE, so that it can meet the technical aspects, economic aspect, and has complied with the grid code and standards that apply at PLN. Government support in this case is needed to determine and emphasize the implementation of a grid code that accommodates the issue of system reliability due to VRE injection. Solution to maintain system reliability due to VRE injection will have an impact and additional costs, which are separate challenge in the development of VRE in power system. In addition, the determination of the party who should bear the additional cost is also an issue that needs to be followed up by the government. The VRE development plan, especially PLTS, includes PLTS Lite, PLTS DDZC, and PLTS Grid connected to the system. Meanwhile, PLTS Loop is not considered to be part of the additional capacity of PLTS, provided that A, the capacity of the rooftop PLTS is limited according to the capacity of the PLN system. B, the impact of rooftop PLTS on PLN's BPP will increase the subsidy and compensation burden. C, there are no transactions in the rooftop PLTS business scheme. VRE development strategy with battery energy storage system, BESS. Variable renewable energy VRE generators are characterized by the nature of uncertainty and variety due to fluctuation in power from the sun due to cloud movement and fluctuation in wind speed in wind power plants. Combine the battery energy storage system BSS with a VRE generator will reduce the intermittent nature of the generator. There are various functions of BSS which are hybrid with VRE generators, such as black start, peak shaving, frequency regulated, frequency smoothing, and as farming capacity. The following are types of storage and their applications in electric power systems as shown in Table 2.1. Genesis storage dan aplikasinya pada sistem tenaga listrik. In achieving the energy mix target from NRE of 23% by 2025, the use of VRE generator in the electricity system in Indonesia will be massive, especially solar PV, both connected to high voltage level and distribution. The use of BESS in hybrid with VRE generator to reduce fluctuation in power output, reduce variability and power adequacy according to demand, so that it can function to be able to compete with conventional baseload generators. BSS applications that are hybridized with VRE generators include: first, using BSS as a frequency regulation which reduces the variety and fluctuation is the output power of VRE generators, so that the power output becomes smoother and does not cause voltage and frequency fluctuation in the electrical system smoothing function. Second, the use of BSS as farming capacity in VRE generators can provide a more certain output with sufficient power according to demand, so that it can provide added value to VRE generators to be able to compete with conventional baseload carriers. However, from an economic standpoint, high costs will be required because the best concept as farming capacity will require large capacity. Basically, in the development of VRE, it is necessary to pay attention to the system requirements for additional generators and system readiness so that reliability is maintained. In general, the use of VRE will more or less affect the reliability of the system. So in some systems, a VRE is needed that is equipped with the battery both for smoothing and for farming. The use of the battery for smoothing needs is usually used so that the system voltage and frequency remain within safe limits. The same goes for farming needs, but for the second, it is usually required for the system whose quota for adding VRE generators has been exceeded. For farming, usually the battery requirements are relatively large. With battery prices that are still expensive, VRE within farming battery requirements will face a big challenge because technically they have to compete with reliable base load generators such as PLTU and PLTA. And finally, must at least be equivalent to operating costs at base load or not higher of the marginal cost of the system. PLN and consultant RUPTL have conducted studies regarding VRE quotas that can be absorbed by PLN's large electricity systems. Each system has a different quota according to the power of the system to receive VRE and system requirements for a particular type of generator. That's all. Thank you.